This is a model motor I bought just to demonstrate how they work, and it's actually kind of cool. I mean, it's got some nice features. It shows you the plus and minus. You can see how everything works. It's got the brushes and the bearings on each end, the magnets and so forth. Yeah, I've made a few improvements on it. It's had some issues, and I'll talk about those issues. We'll do a close up and run it, and I'll show you what happens. But let's look at some of the changes I made. When I first got it, it didn't like to really run. It took too much voltage, too much current. So one of the first things I tried doing is putting a little grease on here. So I've got some aluminum grease on the bearings. And also, it liked the shaft liked to go back and forth, and it would jam and whatever. Especially the commutator here would jam into the plastic. So I put a plastic washer here, and then I put some washers here to help limit the lateral movement of the shaft. So I've brought that way down. Okay, let's look at something else. I'll reorient, and then we'll show you another thing. You might notice that there is a huge gap between the magnet and the rotor on this side. And on this side, I flipped the magnet around to make the gap much smaller. You can see that. There was another bit of oddness. When I got this, there were two magnets like you see on this side, but only one on this side over here. And when I tried taking the magnet off on this side, it didn't want to run very well at all. I mean, it required much higher voltage than it should have taken, and much higher current. So I put the magnet back and it works. So apparently they miscalculated when they made this mount right here. They got it too far away. And so now it works much better if I take these magnets out, flip them around. I might as well just do that, show you. Flip it around so that the gap between the rotor and the magnet is much smaller. Let's run it on 1 volt, see what happens. You hear the motor changing speed? It's going to do that. Now when I remove this, it still works. If I flip the magnets around, you notice without this magnet it doesn't work very well. If I put this magnet back in here, there we go. Yeah, if I put it in the correct orientation with a wide gap like this, it doesn't want to run without the second magnet. Whoops, got to put it in there, the right orientation, there like that. And now it doesn't even want to run at all. It takes more power to run it. If I turn the voltage up, it'll run again, but there we go. It takes about 3 volts to run. Okay, we'll turn it back down. And we'll put it back at 1 volt so we have a standard. There's 1 volt. We'll reorient the magnet so it runs. There we go. Put that one back on there. Now let's listen to how it changes speed. After a time, it's going to start, going down in speed. You hear that? I'll give you a hint. It has to do with these brushes right here. And if I do this, don't do this at home. If I touch this, slows down at first, but then it speeds back up. You hear that? I'm adding lead to it. And lead is a lubricant, but there's something else going on. These are just inexpensive copper tabs, and they're touching a copper commutator, and they're arcing. And when I was a kid, I learned this the hard way. I had these little sheet motors like this, and at the time the manufacturing wasn't very good, so the little bronze end pieces would fall off, the little contacts would fall off, and I couldn't figure out why. I'd bend the little pieces of copper back in position, and yeah, it would work, but not for very long. It would start to slow down, just like this one does. And the problem is you get arcing between the copper commutator and the copper brush. And yeah, copper oxide is a really poor conductor. So when I add the lead to it, it actually works. Don't do the lead at home because it's dangerous. It throws lead dust and whatever. But yeah, it's a demo. It's okay. But yeah, this is one of the drawbacks. Is the design of this is, as a demo, is okay, but if you plan to run it for any length of time, it'll start to slow down, and yeah, and it doesn't hold up very well. For a short-term demo, it's not too bad. You're not going to be able to hook it up to anything and run it for long periods of time, but it's for demonstrating to maybe a classroom or just maybe learning for yourself. It's not too bad. Okay, well, I hope you found that useful and interesting.